Good morning, my algebros. Well, I had a student reach out to me and ask if I would make a video, not just the solution set that's posted, but a video of these solutions to walk you through it. So here we go. We did the first two in class, but just in case, this is how we do perimeter problems. The first thing I do is I sketch them out, right? You can see 1 and 2 are both perimeter problems. And with that, we know that's a perimeter of a rectangle. So we draw the rectangle and we label the parts. We know that every rectangle has 2 widths and 2 lengths. So we know the perimeter will be the measurement of the outside, which is those 2 widths plus the 2 lengths, right? Here they tell us how big that is, how long that is. So we know that there's 2 lengths plus 2 widths equals 56. The other part that they tell us is what one of the sides is. In this case, they tell us that the length is 2 more than the width. And notice I put the 2 at the back because it's a positive 2. But if it were a negative 2, I would want to make sure that that negative would stick with the 2 and not be confused with the W. All right, now we solve by substitution in this situation because that's how it's set up. We substitute the width plus 2 for the length because that's what it says the length equals in the first equation. And now we just do what we did in chapter 1, which is solving for a variable. I have to first evaluate this expression using PEMDAS and then combining my like terms. And now I can finally use SADMEP to isolate the variable using inverse operations. I first subtract the 4, and then I divide by another 4, as it happens to be, and I get the width is 13. So if the width is 13, then I can solve for the length because that's just 2 more, right? 2 more. So I know that the length is 15 and the width is 13. Now I can always check it. Right? That's what the great thing about these problems is when you substitute them back in and check them, they have to equal the right answer. So you always know whether you're getting these right or wrong, and then you can figure out what's going on wrong if it's not adding up, right? Because we use logical reasoning because God gave us a brain. Okay, let's look at number 2. Remember, you can always pause the videos if I'm going too fast. Number 2, we also did this one in class, but let's go ahead and review it again. 2 lengths plus 2 widths equals 132. In this case, the length is 4 more than the width. I substitute in, and then I solve using PEMDAS first, evaluating this expression. And now I can SADMEP to solve, subtracting the 8 and dividing by 4. And in this case, we find out the width is 31, and we substitute back in to solve for the length, and we find it's 35. And we add 2 lengths and 2 widths. We do get the same perimeter. Okay. Next, we went on to do our rate problems. Rate problems has to do with some person, place, or thing and the current that it is getting help from or hindrance from. It's either with the current or against the current. There's a whole separate video on this as well that's been posted. But let's walk through these problems, right? We did some of these in class, the example problems. So the distance we're talking here is 75. So it's rate, that's like miles per hour or kilometers or whatever, and the time it took, right? In this case, all of the rates are with the help of the current, that's positive, or the hindrance against. So if it's with the help, it's going to take us less time, and with the hindrance, it will take us more time. So if it takes 5 hours, that's going to be against, right? A negative factor, a negative pole. And with the help of, it's going to be the shorter time. And now we just use our algebra skills here. It says rate times time and it's parentheses. So we use the distributive property. We just need to distribute here. So we distribute the 3 and we distribute the 5, and then we solve by elimination, right? Which we've been doing for a while now. So always eliminate the y's because they are opposite each other, right? One's positive, one's negative, and everything's going to be the same. The x's are already going to be 15 to eliminate, and the y's, but you'd have to do an opposite number. Okay, so anyway, we're going to multiply the top equation by 5, and the bottom equation, everything when you distribute to the entire equation. Don't forget about multiplying 5 times 75. And then we multiply the bottom equation by 3. Everybody by 3, right? And you can see now our y's eliminate, and we can solve for our x's. And we get 20 and the x is always the noun, the person, the boat, the plane, the bird, whatever, and y is always the current. To solve for the current, I like to substitute into the simplest equation, the first one, and I substitute that 20 in for x, so I can solve for my current. And in this case, this water current is going to be 15 kilometers per hour, right? Okay. On number 4, we have a plane flying with wind, right? So we know that the distance is going to be that 240 kilometers, and that's not going to change. And we know that it took 2 hours to travel this distance, or 3 hours. So the 2 is going to be with the help of the wind, and the 3 is going to be against the wind, and the distance stays the same. Again, we go ahead and distribute, and then we decide to eliminate the y's. So I multiply the top equation by 6 and the bottom equation by 2 because our common multiple is 6, right? I'm sorry, I multiplied the top equation by 3 to get to 6. And then I add these two equations up, eliminating the y's, solving for the x's, and I get that the plane is flying 100 kilometers per hour, which is reasonable. And then I substitute it back in to the first equation because that's always the smallest one. And I isolate and solve for my wind. So we know that the airplane's going 100 kilometers per hour and the wind is 20 kilometers per hour, which is pretty reasonable again. If you get weird numbers, you should always check that, right? Because these are real world situations. So if you get something funky, you should check it, right? All right, here we have quantity and value problems. So these are all the different kinds of quantity and value. This jar that contains quarters and dimes. So the quantity is how many coins, and there's 55 coins. And the value, they have to tell you how much is in here, right? We know the value of a quarter is 25 cents and the value of a dime is 10 cents. And they tell you the total value is $8.50, right? We're just trying to figure out how many coins of each kind. I always like to eliminate the smaller number. That's just how I like to have a good system. Plus, multiplying anything by negative 0.10 is quite easy. So I multiply the top equation by negative 0.10, everything, including the 55. Make sure you distribute it to everybody because it's the equivalent equation. And the bottom equation I don't change because I want to eliminate those dimes and find out how many quarters I have. When I do this, I find out that I have 20 quarters. And then I substitute back into the easiest equation, the top one, to solve for how many dimes, right? Now, on these, you can check all of these to make sure you know that it's right. Because we know the value of $8.50. It has to add up to that. So if I have 35 dimes at 10 cents and 20 quarters at 25, will that equal the $8.50? Well, 35 dimes is $3.50 and 20 quarters is $5, and the total does equal to $8.50. So these are great because you know if you got it or not. if you take the time to check. All right, let's clean this up and go on to number 6. Number 6 is a different kind of quantity and value question. It's saying that we have admission to a high school football game and there's $3 tickets for students. That must be the value of a ticket, right? The value is $3 for a student and $5 for an adult for the total amount that was collected of $3,000, right? So value is always about the money. The quantity is how many tickets were sold, and that how many were collected was 720. Of what kind of ticket? Well, student and adult tickets, right? So remember, value is about the money, and quantity is like how many. This happens to be how many tickets. Sometimes it's how many pounds or how many whatever, right? How many quarters. But this one is how many tickets and how much money was each ticket for a total of what was sold. Now we just solve using elimination. Again, I like to eliminate the smallest number, so I multiply the top equation by -3, everybody in the equation, and I leave the second equation the same. I add up to eliminate the students and solve for the adults as 420 tickets, and I substitute back into the top equation, which is the easiest one, to solve for how many students, right? Again, I can check this because it should add up to $3,000. If I have $3 times 300 tickets and 420 tickets times $5, that should equal our total amount of $3,000 sold, right? So 900 for student tickets, 2,100 for adults. That does equal 3,000, so we know we did it right. All right, let's move on to our candy store questions and our coffee shop questions. So on number 7, we have gummy worms for $1.05 a pound. That's what they're worth. So I'm going to start with the value part, right? Is mixed with Swedish fish, which are $1.35 a pound, right? The total value that we're selling is for $1.17 a pound for 30 pounds. So I have to make sure that we include what this new mixture is going to, the total value of the new mixture. And then the other quantity one is about fish and worms for a total of 30 pounds. So again, the quantity is always about the money. Sorry, the value is always about the money, what it costs. What does it cost for gummy worms? What does it cost for fish? And what does it cost for the 30 pounds of the new mixture? So you have to take the price per pound times how many pounds. The quantity is just how many pounds. How many pounds is this new mixture? And it's worms and fish for 30 pounds. Again, I'm going to eliminate the smallest things. I'm going to eliminate the worms. So I multiply the top equation by -1.05, $1.05 to everybody in the equation. And I add it up, eliminating the worms and solving for my for my Swedish fish. Funny. Okay, so I get 12 pounds of fish in this new mixture. I take the simplest equation again, and I find out how many pounds of gummy worms are going to be part of this. So this mixture will have 18 pounds of worms and 12 pounds of fish. Okay? All right. You could check it. I'm going to move on to number 8. Number 8 talks about coffee, and it doesn't label the coffee. It doesn't say that it's like Kona coffee or whatever. I think on the test, I'm pretty sure I labeled the coffees for you, but if it's not labeled, I'm just going to choose to use X and Y here. I'm going to call my first coffee X and my second coffee Y. And it first tells me the value of these coffees. So coffee X is worth $3.75 a pound. And coffee Y is worth $4.35 a pound for a total of $4.11 for 40 pounds, right? This has got to be more than $4.11. If I just put $4.11 per pound, $3.75 plus $4.35 will not equal $4.11. So I know I have to multiply it by the new amount that we're going to sell. Okay. Quantity is our X plus Y coffees equals 40 pounds total, right? So value is the money. Quantity is how much? The pounds. Again, I like to eliminate the smallest amount, which is 375. So I'm going to multiply the top equation by negative 3.75 to everybody in the equation. And when I add up, I can solve for my Y kind of coffee. And I get 24 pounds of the Y value coffee. And then I substitute it back in to solve for the X kind of coffee. And in this case, our X coffee, our $3.75 a pound coffee is 16 pounds. And our Y coffee is 24 pounds. So, yeah, that's what makes up this 40-pound mixture. All right, you guys, I will see you on Monday and Tuesday, and we'll review this again, and then you'll get your study guide. We have a few more things to review, and then you'll have your test coming up. All right, take care. Bye.